Hello and welcome back. So in today's video we're going to get into talking about sheet metal. Now we use sheet metal quite a bit in manufacturing today, and a lot of companies and a lot of different businesses utilize different sheet metal creation softwares in their business models. Inventor has a sheet metal environment, as does SolidWorks, and a whole lot of other different types of solid modeling programs. I'm going to go ahead, basic commands that we can utilize in the sheet metal environment inside of Inventor. So let's go ahead and dive on in. Now, first thing to note, when we go to start a new part and we know that we're going to be using sheet metal, we want to go into the sheet metal part itself. So there are two different types of IPTs depending if we're creating just a regular part or a sheet metal part. So I'm going to go ahead and click on the sheet metal part and create it. Now, first thing you should notice when this sheet metal part opens up is that our ribbon is completely different from our normal part. We have a sheet metal tab that is our main default tab that we're going to be using. And if you look, it's got a whole bunch of different commands that we don't see inside of our 3D model tab itself. Now, this is by design because we want to think of sheet metal a bit differently than if we were just machining up a part itself. And something else that we have to take into consideration whenever we are creating a sheet metal part is the material itself. Sheet metal is usually 0.25 inches and smaller, so it's very thin material, which means that we have to be mindful of how we bend and break the piece in order to get our finished product. Now, the nice thing about the solid modeling programs is that they do all this work for us. Before, when we were using 2D CAD or even by hand, we had to come up and calculate all the extra material that we would need for bends and everything else. We now have the technology that it kind of does that for us already. But for it to calculate and do this for us correctly, we have to go in and set up what's known as the sheet metal defaults before we even begin to create a part. So I'm going to go over and click on my sheet metal defaults, and you'll see that we can set up different rules. Inventor does come with just a default inch and default millimeter, and we can also pick the material, and we can also set up unfold rules to have the program follow. Now, looking at the unfold rule, it has something in parentheses there called K-factor. K-factor basically boils down to how our neutral axis is located and the size of that particular neutral axis whenever we bend it. So depending on what we set our K-factor to, it will determine where our part is bent from. Realistically, we are going to be using a K-factor between 0 and 0.5 for regular applications in the real world. Now, that's not to say that we can't set a K-factor to 1 and have some uses for it, because there are some uses for it. But when we're talking about actually going in, bending metal and forming it into a product, it usually falls between that 0 and 0.5 K-factor range. So what I'm going to do is I'm going to go ahead and set up my sheet metal defaults before we get started. And the part that we're going to create today is just a small little actuator bracket, and it is going to be 16 gauge mild steel. So I'll need to go through and set up all of the proper rules that I want to use before I get to using my sheet metal commands. So that's what I'm going to do now. So I'm going to go ahead and I'm going to click and edit my sheet metal rule, and I am going to come up and create a new local style, and I'm going to call this 16 gauge mild steel. And my material, I think you can guess it, it's going to be mild steel. and the thickness is I'm going to set at 0.0625. Now going through and looking at this, we also have bend and corner setups as well that we can kind of set the default as to what we want it to be. And so what I'm going to do, I'm going to go ahead and change my relief shape to round, and you kind of see Inventor gives us a preview here to where whenever there needs to be a relief cut, it's going to be rounded instead of straight. And for my bend radius, I am going to go ahead and make that the thickness times 1.5. So I've got my sheet metal rule set up for my 16 gauge mild steel. So I'm going to go ahead and hit save and close, and I'm now going to go in and I'm going to create a new unfold rule. So I'm going to edit that one, go ahead and click new, and this is going to be V-bend 16 gauge mild steel. So this allows us to go in and set how this particular material or this particular rule is going to unfold our material. And so I'm going to keep my unfold method as linear, but you can go in, you can set bend tables, you can come up with custom equations of how you want it to bend, but I'm simply just going to leave it as linear and let Inventor do the work for me. I'm going to change my K factor though to 0.41 and then save and close. So now that I have those set up, I want to go in and make sure that in my sheet metal defaults menu I am selecting those rules that I just created. So there I have my V-bend for my unfold rule, and then I've got my 16 gauge mild steel as my sheet metal rule. And you should notice if I have my thickness from rule checked, the thickness here changes to 0.0625, and the material is set by the rule. You see it changes here to mild steel. So I'm going to go ahead and hit OK. Now that those are set up, we can actually get in and start creating the part. And you'll see why we set those up from the get-go whenever we start actually making pieces of our part. So let's go ahead and start doing that. Alright, so what I'm going to do is similar to our regular parts. I'm going to go ahead and start a sketch, and I am going to sketch on my XY plane. I'm going to go ahead, use my 2-point rectangle, and get my shape for my first portion of my sheet metal part ready. And I'm just going to go in and add some cuts at the corner and a few half slots and a circle in the center. So I'm going to go ahead, get that set up, and I'll see you on the other side. Okay, so I've got my base feature basically set up for my sheet metal part. Now I'm going to go in and I'm going to use the face command in order to create this feature of my sheet metal. Now the face command is going to act a lot like the extrude command, to where I pick my profile that I want to use. And once I have that picked, you'll notice that it automatically extrudes it out to the distance that I need. Now, you're like, okay, well, how does it know that? The program knows it because we set up the sheet metal defaults as 16 gauge, as 0.0625 inches. So no matter what I create, being a face or flanges or whatever, it's always going to use the thickness of my material. So that's why it's important that we set that up ahead of time. But I'm going to go ahead, hit OK. And there you go. And you should notice that it also automatically sets the material to the correct material. So my face here is actually mild steel. So pretty cool. So now that I have my base feature, my first face created, I'm going to go in and I'm going to use the flange command in order to make some bends or some extrusions off of that face. So if we go up here, right next to face, we have the flange command. So I'm going to go ahead and I'm going to click on that. And it should bring up a menu that looks like this. And from here, we can go in and select pretty much any edge that we want to, and Inventor will create a flange coming off that edge, or a bend coming off of that end for us. So what I want to do, I want to create some 1/2-inch flanges coming off the back of my face. So I'm going to go in and I'm going to change my distance here to 1/2 inch, and over here we have some height datums that we can set. So if we want to bend from the intersection of the two faces, we can set that. If we want it to bend from the intersection of two interfaces, or parallel to the flange termination detail face. So there's different ways we can set this up, as well as our bend position. If we want it to start at the inside of the bend face, to the outside, or the adjacent. So there are options there for us to choose how this bend starts. Now for this particular part, I'm going to go in and I am going to select the outside of the base face extents. So now I have that all set up. I'm going to go in. There we go. And select my two edges there. And you see that preview, it shows us my bend there. And the neat thing is I can go in and I can do multiple bends as desired. So this is kind of what I want to use going forward. And you'll notice, I'm going to go up to my top view here, I used the outside of the base. So what that does is it pushes my bend towards to the outside of that face. So if I look at my edge and I go straight down, it's going to be in line with the edge of my first feature. So I'm going to go ahead, got my settings how I want, I'm going to go ahead and hit OK. And now I have those two flanges coming off of my actuator bracket. So what I'm going to do now is we're going to go in and we're going to edit one of these flanges. So to edit this particular flange, I'm just going to go in like I normally would with a regular part, and I'm going to sketch on the outside of that flange. And what I'm going to do is go in, sketch the profile that I want to add to it, use my face command in order to add that to the flange, and then from there we're going to mirror that and do some bends as well to get our final result. So I'm going to go ahead and sketch this up and fully dimension it, and I'll see you on the other side. Alright, so there I have my finished sketch of the edit I'm going to add to the end of my flange. So like before, I'm going to go in and use my face command, select my profile, and again it's automatically going to do the size of the sheet metal material and join it just like anything else. So I'm going to go ahead and hit OK. And there we have that new flange with the modification to it. So now that I have that completed to one side, I'm going to go ahead and mirror it across to the other. So I'm going to use my mirror command, select my face that I just created. My mirror plane is going to be my YZ plane because it splits my part. And once I have that selected, hit OK. And there we have that modification to the other side now. So next thing, we've mainly been talking about how we add material. We're going to look at how we cut inside of sheet metal. So we're going to create a slot cut on one of our flanges and cut all the way through to the other side. So I'm going to go ahead and sketch that up, and I'll see you on the other side. Alright, so I've got my slot sketched up and I'm ready to go. So in order to cut, I'm going to come up and use the cut command on my sheet metal tab. And it's going to act just like if we were using the cut feature inside of an extrude. I pick my profile and then from there set my extents, so on and so forth. So for my extents, I'm going to go through all. Hit OK. And there we have that slot cut into the side on both flanges. So now we're almost done with our actuator bracket. The next thing I want to do is those top two tabs on our flanges, I want to bend those down. So what I'm going to do is I'm going to sketch myself a bend line, and I'm going to use the bend command in order to bend them down. Now, using flange and bend, you can kind of use them interchangeably. I will always argue that using the flange command is easier because you do not have to sit there and try and figure out exactly how this bend is going to work. I just think flange is a lot easier in order to set up how you want your finished product to look like. Bend is going to take a little bit more time and possibly some math in order to figure that out. But in this case, we've already have our flanges made, and we're just going to bend a tab down on the flange. So I'm going to go ahead and sketch that bend line up, and I'll see you on the other side. Alright, so I'm going to go in and I'm going to select my fold line. Now that I've got my sketch set up, I'm going to select fold. I'm going to go in and I'm going to select that line, and you should see two arrows pop up. Those arrows indicate what is being folded and in which direction it's folding. Now my arrow is pointing up right now, indicating that this small tab is what's going to be folded. Now I can flip my controls around, and now what will happen if I flip that? That means the entirety of my actuator bracket will be folded up 90 degrees. Now, we have to be careful, because if we accidentally flip our controls and we fold something or fold the wrong portion, we can create a problem for ourselves in the future. Because if I do fold it this way, then my origin and my origin planes are not going to be the center of my part anymore. So you have to be careful. Make sure that you're paying attention to both of those arrows whenever we're folding something. So I've got my bend line selected. It's folding in the correct way. The correct piece is folding. We can go ahead and set the fold location. We want to, now here, let me zoom in a little bit. That red portion right there indicates where the bend will take place. So I want to change this to the start of the bend. That way everything above my line is where that fold will take place, and where we will see our bend actually appear. So I'm going to go ahead and hit OK. And there we have that portion bent down. Now we need to go and do this to the other side as well. but we don't have to go through all those same steps. What's cool about sheet metal is I can go in and use the mirror command and mirror that fold across my YZ plane, and you already see it's giving me a preview. I can fold down the other side with just using a mirror. So that's pretty awesome. It saves us a lot of time whenever we have a lot of similar bends in our product. So rotate it around, get a good look. That is our finished actuator bracket. Now, if you remember in the beginning of the video, I was talking about how Inventor calculates all the bend allowances and extra material that we need. So this is the part that's really going to blow your mind. Because now that I have my finished product, I can go up to this button up here. It's called Create Flat Pattern. And when I click it, it will create a flat pattern for my finished product. So that's pretty amazing, to where I can get the pattern I need, put it on a piece of paper, I can trace it out, cut it out, hand it to a fabricator, and he can get on his way. It is astounding what we can do with this. So I'm going to go ahead and click it. And there we see our actuator bracket in the flat. Now, word of caution, you have to have your sheet metal default set up properly before you attempt a flat pattern, because if your thicknesses don't match, if you're not using the correct material, the flat pattern will not work. So we always have to make sure that those sheet metal defaults are set up correctly. It's very, very important whenever we work inside of sheet metal. So now that I have that created, I'm going to go ahead and click on Go to Folded Pattern, or excuse me, Folded Model, not Pattern. So now if we look over in our browser tree, we have two separate occurrences, I guess, of our part. We have the folded model, which shows everything that we did, and we have our flat pattern. And we can flip between the two back and forth as we need. Now, another word of caution, anything that we do inside of the flat pattern will not, I repeat, bold, underline, will not be reflected in the folded part. If we want to make any changes, we have to do it inside of our folded model. So anything that we do outside of the folded model isn't going to show up. So just remember that. So we have our actuator bracket complete. I'm going to go ahead and save it, and I'm going to switch over and switch gears and go into a drawing, because there are some neat things that we can do in our drawings with sheet metal parts. So I'm going to go ahead, come up here, start a standard IDW, and I'm going to go ahead and save this guy. And we'll save this as the actuator bracket. Alright, so back to drawing. Inside the drawing, I can place my sheet metal parts just like any other model that I create or part that I create. Let's bump the scale up here. Let's go to 3:1. There we go, that looks better. So my little actuator bracket there, I'll go ahead, create side view, create a top view, and let's go ahead and create an ISO view. Okay, so I have my three views. That is going to be hard for any fabricator, no matter how good they are, to create that exactly as we have it pictured, even with dimensions. When it comes to creating drawings of sheet metal or any type of folded metal, we always want to include a flat pattern, because that flat pattern will give us the exact location that a brake operator needs to hit that piece of metal in order to bend it correctly. So I'm going to come back up here and I'm going to do a base view again. Now if you notice down here, when we're in a sheet metal part, we have this extra option down here to create a flat pattern. And as soon as I click it, you'll notice that it switches over to my flat pattern. Now this option is only available if you create a flat pattern in your 3D model. If you do not create it inside the 3D model, it's going to be grayed out on the screen. You're not going to be able to select it. So make sure you create your flat pattern before you get into your drawing. So I got my flat pattern. I'm just going to drop it right there on my drawing. And I'm going to zoom in here because if you look, it gives us fold lines here. The fold lines indicate where a brake press needs to hit this particular piece of sheet metal in order to bend it properly. Something else that we can do on our sheet metal parts is in the Annotate tab. So if I switch over there, and under our feature notes, you'll see we have something called a bend note. We use bend notes in sheet metal. So if I click on that and then select my bend line here, it will give me the radius at which I need to hit it with my tool, the direction going down, and at what degree. So 90 degrees. Pretty amazing. So I can go through and I can do this on every single bend that I've got on my flat pattern. And from here, typically you want to fully dimension out the flat pattern as well. You want to give your overall size of it. For example, dimensions for these slots here, our hole where these notches are located at. It's just like a complete separate part that we need to fully dimension for a fabricator. So that is pretty much all I've got for us today on our sheet metal environment. And like I said, we're doing this in Inventor. The same concepts are going to apply if we use any other type of solid modeling program. We always want to make sure that we have the sheet metal default set up first and then get into creating our product. Once we're done with the product, we want to make sure that we create that flat pattern. That way we can use it inside of our drawings. So, I mean, thinking back to when we did this by hand or with 2D software, it was a real pain to do all of this. There were charts upon charts of different types of information used with sheet metal. Now that we have these 3D capabilities, it's all built in for us, so it becomes very, very easy for us to create these sheet metal parts. So hopefully this has been eye-opening and you've learned a lot, because sheet metal, like I said, is a very important part of solid modeling. But I'll stop blabbing now and let you get back to creating, and as always, be inventive.